Hello student, in previous lecture we have seen how mechanical element of mechanical system can be treated as electrical element in electrical system based on force voltage analogy. Okay, so in this lecture I will discuss some important point related to this conversion, that means conversion of mechanical translational system into electrical system based on force voltage analogy. So these are the four important points that we need to follow for this conversion. Okay, so first point is, in mechanical translational system, the elements having same velocity are said to be in series. Whatever the elements are in series that have same velocity. Okay, so for example, after mass we are having dashpot, and after that we are having spring. So for example, if the elements in mechanical translational system are in series, are said to be have same velocity. Okay, similarly in electrical system, if the elements are in series, then those elements are said to have same current. Mechanical system, in mechanical system, if the elements are in series, those are said to be having same velocity. Similarly, in electrical system, the elements in series will have same current. Okay, so this is our first point. So first point is summarized like this: in mechanical system, the elements having same velocity are said to be in series. Similarly, in electrical system, the elements in series will have same current. Okay, so this is our first point. Now coming to the second point. So what is our second point? Second point is, each node means meeting points of different elements in mechanical system correspond to closed loop in electrical system. Okay, so generally meeting point is nothing but mass in mechanical system. Mass element in, that is, the meeting point is the mass element in mechanical system. So each node or meeting point or mass in mechanical system can be considered as closed loop in electrical system. Okay, so second point is, each node in the mechanical system correspond to a closed loop in electrical system. Okay, now coming to the third point. So see, in the third point, number of meshes in electrical system is equal to the number of masses in mechanical system. Meshes nothing but a closed loop. So how many closed loop are there means how many number of masses are there in mechanical system, that many number of meshes is there in electrical system. Okay, so third point is, number of meshes in electrical system is equal to number of masses in mechanical system. Okay, so now coming to the fourth point or last point. Okay, so see, what is our fourth point? Fourth point is, the element connect in between two masses, those can be considered as common element between the meshes in electrical system. So here, based on this 4 point, I want to convert one mechanical translational system into electrical system based on force voltage analogy. So here I have considered one mechanical system. So see the mechanical system. So see, here I have considered this mechanical system. Okay, so I want to convert this mechanical system into electrical system based on force voltage analogy. So how I will convert this mechanical system into electrical system? So see how I will convert this mechanical system into electrical systems. So see, in this mechanical system we are having two mass, M1 and M2. Okay, so definitely force voltage analyze the electrical circuit, we have two meshes. Okay, so I am going to consider two meshes like this. That means, see here these two meshes. Okay, so first mesh 1 and mesh 2. Okay, here in mechanical system there are two mass, that's why in electrical system there are two meshes. Okay, mesh 1 and mesh 2. Okay, so here see, in mechanical system I am having M1, and M1 means I need to have inductor here. Okay, so see, I am start from force. Okay, so if I having force in mechanical system, definitely voltage source must be there in electrical system. So I am having force, so I am replacing this force by voltage source E. Okay, so now after that I am having mass M1. After force in mechanical system I am having mass M1. Okay, so if we are having mass M1, so this mass can be treated as inductor in electrical system. That's why here I placed an inductor L1 in the first mesh. Okay, now see, this inductance L1 is related to mass M1. Okay, and now coming to the friction coefficient. Okay, coming to the friction coefficient, that means here the friction coefficient, here I have considered the friction coefficient B, only B. Okay, so see, now coming to the friction coefficient B. Okay, so see, this friction coefficient is only related to mass M1. Okay, so when we have friction coefficient, we need to consider resistance. Okay, so I am taking this friction coefficient as resistance R in electrical system. Clear? Now here I am having dashpot. Okay, dashpot and spring connected in between two masses. Two masses means M1 and M2. Okay, so see the fourth point. So fourth point is the element connected between two masses in mechanical system is represented as the common element between the meshes. Okay, so here whatever the common element between masses are there, that we need to consider in between the meshes. So that means for this spring we need to consider a capacitance, and for this dashpot we need to consider a resistance in between the meshes. Okay, so here we take capacitance related to K1 and resistance related to this B1. Okay, and I will consider this resistance as R1 and capacitance is C1. Okay. Now coming to mass M2. So M2, so see, so now come to M2. So M2 is having, so again inductance L2 in electrical system, and here we are having another spring and another dashpot. Okay, so spring is K2 and dashpot is B2. That means in electrical system another capacitance and another resistance. Okay, so another capacitance we take here C2 and another resistance here we consider R2. Okay, so this is C2 and this is R2. Okay, and this is I1 and this is I2. Okay, so this is the equivalent electrical network related to mechanical translational system according to force voltage analogy. So like this we will model the electrical network from mechanical translational system. Okay.